Okay, so quickly then let's get started. I think we are about to get started now. Sure, great. So good evening, everyone. And this is the 13th day that we are on. And so far the journey has been quite amazing. And thanks to all of your support and thanks to all of you to attend this wonderful sessions with other people also, with Promit, with Vivek, with Namita, with Meg, with Tobias, with Guru, and also with Chris. So it was amazing journey so far. So we are about to end up the journey tomorrow. So today we'll be talking about the decision trees and the random forest algorithm, which will be presented by Anugna, and she's also a data scientist, and she is also preparing for her master's abroad. So I think that will be a good experience for her to talk to such a huge audience. So all the best, Anu. You can put on the show now, and I'll be discussing about the Slack, the third task that we are about to. We are extending the timeline by today night, the midnight in Indian time, or you can say wherever you are based. So today is the last day for the submission. We have extended because I think many people have been able to submit only the score. I think I just had a word with Yulia also about this. So you guys are supposed to even submit the code, or you can say you can submit the code completely on the Slack as an IPYNB file. Okay, so I'll talk again about this in depth for the last 15-20 minutes. That should help you guys to understand more in depth. Okay, so now over to you, Anu. All the best.
I need that. Hello, everyone. My name is Suram Saraswati Anugna. I'm a data scientist at Fasken Engineers. Thank you so much for such a great introduction. And I would like to say thanks to Yulia for organizing such a beautiful event for everyone. And I have really enjoyed my past 12 days session. I mean, they were really, really good sessions. And I'm just really excited that you guys do enjoy today and tomorrow's session too. So today we are going to talk about decision trees and random forest. As whenever the word machine learning pops up in anybody's mind, the first algorithm that comes to the mind would be decision trees, random forest, and they happen to be one of the best performing algorithms or highest accuracy giving algorithms in some data sets. So, so can I share my screen here now?
Yeah, I think you should be able to share a screen. In case if you are not, just let me know.
Just a second, let me try. So is everyone able to see my screen?
Not yet. Yeah, now we can. Now we can.
Okay.
It's ARM developer. You're showing that.
Okay. You know, if I show you the other slides of other Google tabs that I have opened, people might get scared. I mean, like there are many tabs. So that's why.
Okay.
Okay. So let's begin in the 13th day of the session. Okay. So as I said, we would be discussing about decision tree and random forest. So let's start with an example. Let's juggle our mind a bit. Okay. So if I ask you, what are some good predictors to decide whether you're going to stay in this weekend or not? Definitely, you will say that there are some things that you will think before taking a decision or making a decision, right? So Let's say there are factors like weather, if it's raining or not, if it's too sunny or not. So you see the weather for the weekend. And then if your spouse or your better half is in town or not, a reason, right? To stay in or stay or to go out. Then if there is a game going on TV, like in India, IPL is going on. So I am a Kolkata Knight Rider fan. So yeah, if there is a match of KKR on Saturday and Sunday, then no ways I'm gonna move out of the house. And then comes the boring part that sometimes you have workload and you have projects or something to complete at work. So you cannot go in. Sad case, but happens. So now, do you think these factors have any order or importance in your decision making? Let's find out that. So let's take an instance for me. Okay. So let's say that for me, weather is an important factor. Okay. I don't like my hair to get wet in rain. So yeah, I'll definitely check if it's gonna rain or not. Then second would be work, because you have to work for living. You have to make money for living, right? So work. Then game, as I said, I'm a cricket fan. Game. Since I'm single, so the last one doesn't apply on me, but still, we'll keep it in mind. Okay. So now, just like I said, that whether work, important, game, or spouse, these factors, for me, they are making a set of order. For me, it is important. For somebody else, it might be important. So you see, you can see that all these factors are going to affect my decision. So here you see, if I say, is it raining or not? Then if it's yes, then I'll stay in. I will not go out. And then if I have some urgent work to do, I'll stay in. I will not go out. So you see how this structure is being formed. This is your decision tree. You know, it's that easy. Simple. Simple as it looks. You know, there is an interesting fact. In machine learning, amongst all other machine learning algorithms, except for random forest, the decision tree is called as a white box algorithm. Because in other algorithms, you don't know how that is actually performing or what functions are going on inside that algorithm. You don't get to see those computations and everything. But in this one, you get to see and you get to visualize this tree, right? So you know how your decision is being made, how your predicted outcome is coming out to be. So now let's talk some technical stuff, which is important. So what is decision tree, or what are decision trees? So in machine learning, decision tree predicts the outcome given the values of the input variable. And as everybody knows that it's supervised learning algorithm. And why people prefer decision trees is because it's structured and you can easily visually represent it, and you can it's understandable, right? If you can see something and easily visualize it, so you understand it better. So these are the basic what's of decision tree. Now that we know the what decision tree are, we should know the pros and cons of it, because it's important, right? So as I said earlier, easy to interpret, perfect for visual representation. Like you can draw it yourself, like what are the attributes affecting, if it's a small data set, not for the large ones. But then you see it works for both categorical and numerical or continuous variables. So it's compatible for both, and it's widely used for both regression problems and for classification problems. And the non-linear parameters does not affect its performance. And if just say that you have a complex data where you have to regroup your data again and again and again, you can apply decision tree on it rather than going for linear, or rather going for logistic, KNN or SVM. You can definitely choose this one. Then you don't have to work too much on data pre-processing. It's easy, it can handle it. But as I stated some good pros of it, there are some very bad cons of it, like overfitting. Overfitting, as it tends to pick up the noise, it is the bugger in the decision tree algorithm. I mean, like You cannot expect your decision tree to like come out or model itself without overfitting. Overfitting is very common. Then it has very high variance. And with even little variation in the data, it really gets unstable. The model gets really unstable. And it has low bias. Like when you work with new data, it is a bit difficult to get adjusted with. So now that we know the pros and cons of it, let's know how it works. So here you see, as I said, it's a white box. You can see how your decision tree is working, and you give input variables and you get your output variables or predictors or features. You can call it with any name. So now that we know that decision tree splits itself recursively, like yes, no, yes, no, yes, no, or if then, or if else. It's like if else loop. Chalta rehta hai, keeps on moving, right? So this splitting, the most common strategy that people use is called recursive partitioning. There are types of this algorithm. One is ID3, C45, CART, that is classification and regression tree, and CHAT. So here if you see, ID3 was more of a categorical type of variable. So categorical type of variable. So what happened was it was not good at handling continuous variables. So come the C45. Basically, C45 is the successor of ID3. So till now what we did was we understood what are the pros and cons of decision trees. We understood how we form a decision tree. And then we understood about how the splitting is done. And now there are some keywords in decision trees that you should be aware of before getting your hands dirty with decision tree algorithms further. So if you can see, I have like put a picture of a tree upside down. So you might ask me why. To tell you that the roots come first and the leaves are the end of it. So if you have to understand this, the topmost or the most important feature or most correlated feature with your outcome or predictor will be your root node. And from there, you might have several branches, several leaves. The leaves are always your endpoints. Like you cannot split the leaf anymore. You can split the branches like two ways, because I said it's yes or no, mostly yes or no, right? 0 or 1, spam or ham. So you split it in 2 ways. But leaves are the end node. So your leaves will always be your class label or your predictor variable or your predicted outcome, right? The next comes scary formulas. Okay, so just don't get distracted with these formulas for now. Let me give you an easy example to understand all these things. Imagine I tell you, there are 2 animals in front of you and you have to decide whether it is a hippo or a giraffe. Okay. So you might ask me like, we don't have any information. We don't have any data about it. So now I give you a statement. When I'm telling you a statement, that is that it has 4 legs. Wow. That is not helpful because even giraffe, both of them have 4 legs, right? Giraffe and hippo. So you cannot decide whether it's a giraffe or hippo. So what you do now, you look for the next statement or next data that I give you. I tell you like, it's 10 feet high. So now, okay, yeah, it's most likely 10 feet high animal is gonna be a giraffe, or like you can predict like, yeah, it's giraffe. Otherwise, like, you know, hippos are not 10 feet high. I mean, like I have never seen one, but correct me if I'm wrong. So you see, the first information or the first statement or fact that I provided you with did not help you in reaching to a decision or to a leaf node type of thing.
So here I increased your entropy. Here, when I said it has 4 legs, it's a 50-50% chance that it can be a hippo, it can be a giraffe. And always remember this. When you have an entropy of 50-50, it's the worst entropy for you. It's the worst score that is going to come for you. So, like I have pointed out, entropy. Entropy is the measure of randomness and unpredictability in the data set. It ranges between 0 to 1, 1 being the worst, 0 being the perfect. Anything in between is good. So always we try to keep our entropy to the minimum. When I say we keep our entropy to the minimum, it means automatically we are generating more information. We are having more information gain. So information gain is a measure of entropy after the data set has been split. Just like in the example I told you, that the second one about the height, you were able to arrive on a decision that, okay, it might be a giraffe, right? So second one, you can say it was an information gain. The first one was an entropy gain. Gini impurity is similar to entropy, but it is widely used, more popular. Why? Because it's computationally efficient than entropy. As you can see, there are logs and all in entropy. Gini impurity keeps it simple. So it's just square that thing up and you get your answer. So now that we have discussed about these examples, I think these formulas are quite daunting. So even I struggled with them for some time. So let's just try once and we can like compute it right now. I have an Excel sheet prepared so you guys can see and see the working of how it works. So before we leave the screen, so let me just read out the formulas for you. The entropy is often represented as H of S, which is equal to the negative summation of Pi. Here we take it as the P positives, P negatives. You will understand this later when you see the formula in working. Just bear with me for now. So we have Pi log base 2 of Pi. Then for the information gain, we use the entropy of S. This is the entropy of the root node. And further is the entropy of the whole tree in summation. So what happens is when the tree starts using information gain as its splitting criteria. So what it does is it will take the entropy value of the root node and then it will calculate the entropy of the whole tree and average it out and then subtract it from this one, right? Oh, sorry, not average it out, add it out. It will add everything and subtract it, sorry. And then comes the Gini impurity, which is Pi into 1 minus Pi square. If you multiply it, it's going to come Pi square. So let's see the
Anu, before proceeding with that, can you give an example for entropy?
For entropy?
Yeah.
Just like I said, when I give you okay, entropy would be creating more confusion or giving you unpredictable outcome, right? So if I say that you have a bunch of animals in front of you, standing in front of you, and I tell you to give me the decision of like what animal is what, like you have to label all the animals. So unless you have some criteria to split them or like color or height or weight, until then you have a high entropy in front of you. Like it's a mixture, it's creating confusion for you. It's not clear for you what is what. So that is entropy. So in our decision trees or when forming a decision tree, we try to keep our entropy to the minimum. Then only we will have information gain to the maximum.
Okay, that is perfect.
Good enough?
I hope, Virisha, you have understood the option. I mean the entropy part.
Okay.
Yeah.
Don't worry.
Go ahead.
Right now, you will like have a clear picture about entropy now that you see how it's working. See. Now, here I have created a small data set type thing. Okay. So let's say there are 3 features and I have formed a decision tree of only one maximum width of 1. And here I'm saying that that decision tree is a binary classifier. Okay. It is the outputs are either yes or no. Okay. So in this case, let's say for my feature for F1 here, I have 9 yes and 5 no's. Okay. And for when I further split it into F2 and F3, what happens is I have 6 yes here and 2 no's and 3 yes and 3 no's. So let's calculate the entropy for this particular node. Okay. How do we calculate it? As I said, the entropy is given as HS. Okay. Here, first you will take the value of the positive, that is your yes. Let me tell you, this is impure subset here, right? You have to further divide it more to get the pure subset. That is your homogeneous one, which is only yes and only no's, right? Here, I'm for the sake of example, I have stopped it here. Otherwise, you have further, like what do we say, splits going on. Like one more split on each side will happen. So here, H of S is minus P positive. That's why I've given it as P1. Okay. And then we take the log of P1 and then we go for P2 and log of P2. So here, if you see for P1, what are we doing is we are calculating how many positive values we have, positive being yes. So we have 6 and total number of outputs that we get here is 8, like 6 plus 2, 8. So we do it as minus 6 by 8 log of minus 6 by 8. Here it's not direct log. Sorry, I have forgot to put base 2, but you have to calculate it for base 2. Okay. Then for the negative side, now you have calculated for the positive side. Now you have to calculate for the negative side, the no's, right? So what happens here is that we have our 2, the total number of no's that we have, and total number of subsets here is 8. So 2 by 8 log 2 by 8, right? So if you do the calculations and everything, you should come up with an answer of 0.81. So this entropy is good for now, you can say. But if you see something here, there are 3 yes and 3 no's, right? It's a very impure subset. Like this is the most impure subset that you can find because it's 50-50. You don't know where to go now. So in this case, you will have the highest entropy that is possible, that is 1. As I said, the entropy ranges between 0 and 1. Okay. So for this, if you calculate, you will have an H of F3 is 1. Now that we know how to calculate the entropy, we can move forward to information gain. So here, if you see, as I said, the information gain is nothing but the entropy of the root node minus the summation of all the nodes following. So entropy for the information gain formula is given as gain S comma A. Okay. Here S is the root node and A is the attributes coming in like after the splits. So here, if you see H of S, if this is the root node entropy that you have to calculate. I have calculated it here already with this same formula. So you see here it is 9 yes and 5 no's. So if you put it in this formula, you will have minus 9 by 14 log of 9 by 14 minus 5 by 14 log of 5 by 14. So if you calculate it, you will have an entropy of 0.91. Okay. Going forward, we know that as we earlier calculated that the entropy of F3 is 1. So now here you see the summation SV. This is after the split. This is the value of the node after the split. And this is the entropy after the split is done. So here we have already 2 splits done, right? So we would be adding 3 entropies here. Total 3 entropies will be 2 entropies in the summation side and 1 the main root node. So here 0.94 minus the formula. But here what you have to look for is SV. When I'm saying SV here, I'm calculating for F2. Here if you see it is 8, but the S value here is of the previous node, the preceding node. So here the value is 14. So total number of outcomes here were 14 and here were 8. So here the formula goes as 8 by 14 into the value of entropy 0.81 and minus for this one, you see it has 6 nodes here and 14, the preceding one. So we calculated here. After doing all the calculations, multiplications, subtractions and everything, you get a gain of 0.049. Not that great, but fine. It's fine. Unless it's 1, it's fine. So now, as I said earlier, that entropy and Gini impurity do the same thing, and like they are pretty much similar, but different in formulas. So let's try to calculate the entropy for this one, where I said you have the worst possible outcome, like worst possible subset here, impure, most impure subset that you have reached here. So here when you were calculating with entropy, you got a value of 1. But when you apply a Gini impurity into it, you get a value of 0.5. So it's not that bad. You see, compared to 1, 0.5 is better. And the time that took me to do this one was far less than in doing this one. Quite complicated. So that's why people prefer to use Gini impurity over entropy. So here in the graph, I have tried to show you guys how these things are working. One thing you should remember is here, if you see, if your positive side is increasing, the positive value here is increasing, your entropy is increasing also. And at 0.5, which is a 50-50% chance of it, you will have the highest entropy, and then it will gradually decrease. Over here, if you see for Gini impurity, you see that the maximum value it will go till would be 0.5. And after that, it will decrease. Clear enough? Let's see if you have guys any doubts or anything. Okay. Are these questions all answered or not?
Yeah, you can even check the answered one also if in case you want to add anything to that.
Okay. For entropy, what else examples can I make for you? Well, Vidisha, I'll get back to you on this. I'll try to come up with some.
I can give a better example, in fact.
Please go ahead.
Yeah, sure. So if in suppose in 12th standard, you must have seen that we used to get some examples for, in a bag of, you can say in a sack bag, when we put up our hand in that and we pick up a random balls. So those balls can be in say, suppose if all the balls are in blue color. Okay. So in that case, the entropy, you can say the variance. Variance means variety of things, right? So in that case, the entropy is very much nil. You can say 0 because all the colors are blue, right? In that particular bag. But now if you come on, you can keep on adding say red, green, brown, say uh, some different color, black, white, and all those mixture of 7 to 14 colors, or you can say 20 colors over there. So in that case, the variance increases because there are so many different kind of variety of balls. Red has a different kind of variety as in the amount of red balls are different, amount of black balls are different, so that increases the variance. You're getting my point? So that is where you can in such conditions you can reduce the variance by sorting out the data and grouping it by. So once you group in by, say suppose you can put up another parameter to it. Say suppose this red ball should be having some numbers to it. Okay, if that is a good example of it. Say suppose in a pool ball there can be a lot of red balls, right? So they can have some numbers to it. So you can group them in one particular you can say parameter. So that will reduce your variance. You're getting my point? So I think this should be a good example if you guys can understand it. I hope it's understandable that this example
Totally
is
good.
pretty much
Totally good.
understandable, I believe.
Totally good.
Yeah. So Birisha, do let me know
So
if you have understood this point. And Shubham, I think I even put up your point together on it to reduce the variance that can be
well,
collected in you can put up a cluster kind of thing. Though
I would like
clustering
to
is
answer
completely
this
different topic.
question.
Yeah, the clustering is
Okay.
completely different topic, but that is something that you can definitely utilize. You can say group by function to reduce the variance. Okay.
So, Shubham, you will get the answer for this, how to overcome high variance in the upcoming slides. So just wait on to that. So let's just continue with this. Now that we have known how to calculate these things, let's go with the next one. So now that we know how we split our tree and how it works and how our decision tree comes to a decision, we should know one thing, that is overfitting and how to overcome it. So before going there, just now that I have pointed out information gain, GNA impurities, different models uses different parameter for splitting. For ID3 and C45, they use the information gain as their splitting model. For CART, the classification and regression trees, they use more of GNA impurities. So that's why GNA impurity is more popular now. And for chat, they use statistical significance, which is nothing but drawing a set of random observations from a population of say 1,000 or 2,000. And we do this so that we can reduce that when we are randomly taking out the samples, we are reducing the sampling error and we increase the quality of estimators in that. So that's how chat works. So let's go ahead. So let's get an example for how overfitting happens. So let's say Frodo and Sam, two friends, they go to a restaurant every day. Okay. And what they did after coming home was they rated the food. Okay. Let's say for Monday, the food was good. For Tuesday, the food was bad, and so on. So at the end of the day or end of the week, Frodo came to a conclusion that overall the food is good at restaurant. But Sam, being particular, he said the food is good at the restaurant except for Saturdays and Tuesdays. Okay. Which one do you think is right? Sam. Okay. Shrishti thinks Sam is right. Anyone else? Okay. Sam. Okay. Bhargav. Frodo. Okay, so majority of people think Sam is right. Okay, let's see who is right. So, okay, so they went home and they started training, applying decision tree on their model, and they saw that Frodo depicted that on Tuesdays food was good, as he said, food was good on all right. So on Tuesdays also he predicted that food was good, and on Saturdays also he predicted as food was good. This is the training model, okay? And Sam, as he said, except for Tuesdays and Saturdays, so 100% accuracy. So do you guys think Sam is right? Let's see who is right. So if you see, Sam's model works best, like 100% accuracy, he's accurate. And Frodo, okay, his model is down 71%. So, but Sam's model is looking good. Now let's see what happens when the testing data comes in, or the test data comes in. So the next week they go for the restaurant. Okay, the week 2. So what happens is, food is good on Monday, on Tuesday. So Sam model goes out. Wednesday it was bad, okay, but both predicted it as good, so that went out too. And then on Friday, everything was fine. Saturday, Sam said bad, but it was good that day. But on Sunday, it was good and both, it was bad and both predicted as good. So if you see, when the training data was working, Sam's model was working perfectly fine, 100% accuracy. But when testing data came into picture, his accuracy came down to 42%. But Frodo, his model is 71% in the training data and 71% when the testing data came in. So now somebody wants to change the answer, that whose model is better? Yes, Shubham, you're right. You got it right, exactly. So if I say overfitting in simple words, it's like you don't need to have 100% accuracy in your model, or like highest accuracy possible in your model. Your model should fit well, should generalize well. Here, if you see, the key to the Frodo's model is it generalizes well. Even when it comes to training, it performed same or okay, but when it came to testing, that is the important data set that you are gonna like actually gonna tell you what is the accuracy of your data set or your model, your model. So whoever said Sam's model was right, I'm sorry guys, you were wrong. Frodo's is better. So though Frodo's model performs well on both training and unseen data, why? Because it generalizes well, as I said in the earlier. Sam's model is more complex because he went onto like Tuesdays, Saturdays was not good. He went too much into depth of it. So it was not like overall, he did not look at the overall of it, right? So it's bad data, I mean, a bad model. It's not going to help you. So that is overfitting. The food at the restaurant was good except for Saturdays and Tuesdays. In training, but Sam's model picked up the relationship between the weekday and the quality of the food, right? And this relationship was only to that specific data set, because when the new data came in, you saw the food was bad on Sundays and one other day, like one Wednesday, right? So as Shubham pointed out, overfitting. So Sam's model was perfect example for overfitting. So now let's get the technical definition of overfitting. That is, overfitting occurs when the model picks up a random phenomena like Sam's model picked up. Food was bad, just like, okay, cook was not feeling well, so it was bad, right? And instead of underlying relationship between them, between the input and output, so it presents the noise as a relationship between the input and output, right? So that is overfitting. So that is bad for your model. Should not have an overfitted model. So let's sum it up now. So far what we have done. So we know that decision trees is used for solving machine learning problems. We know the definition of decision trees good by now. And we know that decision trees are very, very prone to overfitting. So how can we overcome overfitting? We use ensembling to mitigate the overfitting. Now comes the interesting part, random forest. So random forest, before talking about random forest, I would like to tell you about bagging, which is an ensemble technique. So it is also known as bootstrap aggregation. What happens is, just think you have a data set DF, okay? And you have some models, like a number of models of, for now I took 4, right? So what you do is you give each model a certain number of samples, like n number of samples to each model. And then when giving to the first model, right, you give n number of samples to the first model. Now always remember the total number of your samples will always be greater than the number of samples that you're supplying to the model. Okay. So now after giving one set of samples to M1, the model 1, what happens is just a second, guys. I think I just, okay, yeah, sorry. My earphones were acting up. Okay, so now what happens is, yeah, so once this model n samples are supplied to M1, the row sampling is done in the DF. So now the rows are again sampled, resampled, and replaced, and then it is fed to M2. Okay, there is a chance that some of the samples which was supplied to M1 might have come down to M2 also, but it's okay. They have been reshuffled, and it's highly likely that they are going to be completely repeated. Right? So similarly goes on for M3 and M4. So here, till now, what you saw is called bootstrap. Like what you're doing is you are taking some certain number of samples, you are supplying it to one model, then reshuffling it row wise, and then you're feeding it to the another model. So what you're doing is you're using multiple models to make your outcome. And each model is being trained on a certain data set that is supplied to it and giving out an output. So here what happens is, let's just say that M1, the model 1 predicted outcome as 0, and M2, M3, and M4 all predicted as 1. So here the yeas have it and no's don't have it. So the weightage is given to the highest majority. Like if highest is 1, then the final model output will be 1. So what here is happening is aggregation. So this is how it got the name called bootstrap aggregation. Similarly, we can use stacking. Like here we have different models, like it's the same picture of that, but it's more colorful, that's it. So here we have like models, naive-based, support vector machine, and neural networks, and we give n samples by reshuffling it as row sampling and replacement. And then we take the output of each model, and then we feed it into a logistic equation. It's just an example that I have stacked up some models. So by doing this, what you're doing is you're avoiding overfitting, because different model is going to predict different. And here you cancel out the discrepancies or the overfitting issues, and your model comes out with like lowest possible overfitting, or like no at all in some cases. So the best application of bagging is random forest. So random forest, as the name implies, that it's large number of individual decision trees operate as an ensemble, like they work together, like number of trees work together to give out one output. So here, if you see, each tree has a split. Each tree has a split of class prediction, and the most class with the most votes becomes the final model prediction, like I said. whichever will have like 0, 1, whichever will have the highest occurrence will have the will become the final model prediction. So unlike in bagging, in random forest, we don't only sample the rows, we sample the features also. So let's just take an example. We have F1 to F5 type, like F1, F2, F3, F5. These are our features. And we have certain number of rows. So what we'll do is we'll provide the first model, a certain number of samples as rows, and then we will provide F1, F2, and F3 as a subset to the features, as a feature subset. And for the second model, we use F2 and F3 as a feature subset. Like we can like make multiple permutations and combinations. We can apply permutations and combinations over it, and we can like have multiple trees generated in that way. And the majority output will be the output will be the majority vote, right? So the difference between the bagging and the random forest is, in bagging you can use any ML algorithm, but in in random forest you use only decision trees because it's a forest. So only trees are allowed. So what are the applications of random forest? So random forest is used in remote sensing. So if somebody is a satellite geek, they must be aware of ETM device, that is the electronic thermal mappers, which basically maps the areas or take the pictures of the areas which are out of the human spectrum. So basically it's used in images, collecting the images of Earth from the satellite. Okay. Then comes the object detection. So you must have heard about a lot of projects in object detection, like they can tell you if it's a pen or a book or a phone or whatever it is. So random forest is used in that. And why? Because it provides better detection in complicated environments. Like you can have a complex data set and you can apply random forest and it's easy. One other is Kinect. It is the game console, the Xbox, and you know. So basically, it tracks your body movements and it like predicts what if you are saying hi, or if you are dancing, or if you are making some gesture. So it tries to predict. So these kind of applications are for random forest. Now come, why random forest? I believe I had a question about how we can overcome high variance, right? Who was it from?
Yeah, you do have a question. But you can take it up.
Yeah, I had a question here, right?
Yeah.
Okay. So here, in case of random forest, what is the reason for overfitting? What is the reason overfitting is overcome? Here, let me tell you, what happens is when you have an individual tree, right? Your tree is very unstable, and even slight variation in your data can affect the output, right? But in random forest, there are multiple trees, like hundreds or thousands of trees working and giving you the output. So here, what happens is the high variance, which is an issue in decision trees, is converted into low variance in random forest. As I said, random forest works on majority wins, right? So, I mean, one tree might not affect the decision of the random forest, because there are other trees also which are influencing this decision. Am I clear? Like, you understand how we like overcome overfitting and how we overcome the high variance? Okay. So moving on, we use random forest. Why? Because it has high accuracy and it runs efficiently on large databases. So, well, random forest is good for even big data. One of the most like intriguing feature of random forest is that it estimates the missing data. I mean, like if you have a data set of 1,000 entries and you have discrepancies or you have missing data of like 200, say, your model accuracy will not be that much affected by those missing values. Your random forest can handle it. So it is good at handling missing values. So let's move forward. There are other ensemble techniques which can be used to avoid overfitting. That is ADA boost, that is adaptative boost, gradient boost, and XGB boost. So if you, I guess you guys are working on Kaggle right now. So if you see the Kaggle notebooks of the competitions, because I also actively participate in that, I would say like 90% of the notebooks that come in the competitions, everybody is using it, like everybody. It's very, very popular on Kaggle. So there have been a lot of talks about random forest, how you build a model, how you build decision tree, everything. But unless you know what is the, how to measure the accuracy or what is the accuracy of your model, it's of no use for you. So performance metrics. So here I have a very interesting question for everybody. Who all are aware of the terms ROC and AUC? Although I'll take that question after the class, like after I complete the presentation. Okay, Satrupa, you said yes. Okay.
Yeah. Fine, you can take it up after.
Who else?
The...
Yeah, after the session, I'll take that question up. Who knows ROC and AUC? Even amongst my panelists, if anybody knows ROCs, AUCs, if anybody can tell me the full form of ROC. What is ROC? AUC is easy. Anybody can tell that. Okay. Anyone else? Okay. Okay, everybody is saying region of convergence. Okay. Area under the curve, right? As I said, AUC is easy, ROC is not. Not much people are aware of the right full form of it. Okay. No, it's not accuracy score. I'm asking for the full form of ROC. If somebody is aware of like how we use ROC curve. Okay. Okay. Satrupa, you're almost there. Okay. Who else? Yes, the winner is Richa. Very good. Yes, ROC is nothing but receiver operating characteristic. Everybody says ROC, so people just don't know. A lot of people don't know. Even I didn't know till I like looked it up what it was actually. So yeah, which was like a week ago. So ROC is the most commonly used for visualizing binary classifiers, right? Amongst the classification matrices, these two are like not that much touched or not that much explained or used. Why? Because these are confusing, very confusing, because you have to deal with confusion matrices. So the area under the curve is the measure of ability of a classifier or to distinguish and summarize the ROC curve. Okay, these are technical ones that you might not understand, but you don't need to remember these terms. You should know how they work. That is enough. So the one most important thing that you should know about ROC is it is always plotted between the true positives and false positive rates. So true positives on the y-axis, false positives on the x-axis. So they tell me the formula for sensitivity. I actually given it. Oh, okay. I've actually given it. Yeah, I forgot that I added this in the last moment. Okay. Anyways, so let's continue. So sensitivity is nothing but true positive rate, which is sorry, ratio of true positives and sum of true positives and false negatives. And then we have specificity, which is false positive rate, which is calculated by false positives and the ratio of sum of true negatives and false positives. Okay, it's quite like circuit upar se gaya type. It's like you don't understand anything right now. So a quick question: what's the time? It's 8 o'clock. Is anyone interested in calculating the ROC and AUC for fun? Right, Satrupa? Okay. So as Shubham Richa requested, we'll go for the ROC and AUC curve example. We'll take a very simple example, and I want you guys to like work along with me in this. Before that, let me show you how a ROC curve looks like, and then we'll jump onto the Excel sheet and we'll start working. Okay. So as I said, the true positive rate is on the y-axis, the false positive rate is on the x-axis. The area under this curve is the area under the curve that you AUC that you just pointed out. Higher the AUC, higher your model prediction or accuracy. If your area, if your ROC curve is below this linear line passing, then your model is dumb. I mean, don't use it. It's not good model. It's not good model. Then you need to do something about it. So let's do some maths. I've been talking too long. Okay, so here I have, say, I'll give you some values. I believe everybody can see my Excel sheet.
Yes, if everyone is about to follow, then maybe they can open up their Excel sheet or say Google Sheet.
Yes. You guys can open up your Google Sheet. Soham, you also open
let's
your Google
give
Sheet and work.
2 minutes, 2 to 3 minutes.
Yeah.
Sure.
Okay. Meanwhile, I will just type the values here for y.
Guys, do let us know if you are able to open up your Excel sheet and or maybe Google Sheet, and you can work along with us.
Yes. It's fun. It's easy maths. I'm not giving you logarithmic values. Don't worry. It's really easy.
Yeah, this
It's
is
just
not
your observations.
very
It's your
difficult
observation skills and your addition skills.
Yeah. Okay, I think we can get started on that. I think everyone has maybe opened it up, right?
Yes.
Okay.
She says
Perfect.
yes. Okay.
Go ahead, Anu.
Okay. Okay. Great. So you guys can write down these y values or like to work along. So just quickly like copy these y values. So now here y pred, I'm taking it as it's the say the probability in terms of probability. Okay. So here if I'm writing 0.8 means 80%. Chances like 80% accuracy here. So 0.4. now what happens is, based on your model or data set or the data distribution, the the program will come up with some threshold values or give you some threshold values to compare your predictions with over here. Okay, so here let's say we have threshold values of 0, then we have 0.2, then we have 0.4. Let's calculate till 0.6. So now here you will calculate, you'll see if your y-pred is equal to or less than 0, you put 0 there, otherwise you give 1. So anybody want to take a guess about what will be the value in the first column of threshold? It's quite easy. Is everybody following what I'm saying? Yes, Shrishti, we will have all values as 1 because there is no value less than or equal to 0. So just blindly put 1 in front of each of your. So similarly, you calculate it for the 0.2. Here it is higher than 0.2. So 1 higher, then again 1, again 1, 1, 1. Here it is 0.2. As I said, it should be less than or equal to the threshold. So 0. Similarly, if you go for 0.4, what happens is, first one is 1, okay. Second one, 0, because it's 0.4, right? So then you have 1, because 0.6 is higher, 0.5 is higher, 9 is higher, 7, 2, and 0.2, it's low, so 0. So I want somebody to do 0.6. Is anybody up for it? Like simply just see the value, put 1 or 0. Okay. Yes, right. It is 1. Yes, Richard is right. You and Shrishti are right. So it is 1, 0, 0, 0, 1. Sorry. 1, 0. Simple. Now comes the confusion part. So I'm sure that everybody is well aware of confusion matrix. So everybody has their concepts clear when it comes to true positives, true negatives, false negatives. Right? So now what you do is you simply put your, to calculate your true positive rate and false positive rate for each and every threshold value. And while you're calculating it, you will have X value and Y value. You start plotting it. Right? Simple, right? So you'll have a funky type of a graph, but you will enjoy it. So let me just write down the values because I will calculate them. First step for say 0 is 1, and I'm just writing positive here, but for false positive 0 we have the value as 1 again. So what you will notice is as you are calculating and you're going like above on your threshold, you'll see your graph points will come, like they'll start coming down or in the decreasing order. So the highest point that you will always get, maximum would be for the zero threshold value, right? So here we have 1, 1, and then for, let me do this. Let's write PPR here. Just replace these values so you guys can, when I share the Excel sheet, you guys can easily read it. That's good. Yeah. And for 0.2, you will have a threshold value of 0.75. It's true positive. And then for false positive, you will have 1. As you can see, your points are coming and descending on now. They are falling back now. So next comes the 0.4. That would be the true positive 0.75. I would see 0.66. Yeah. And for 0.6, you have true positive rate as 0.5. And you have true positive and false positive rate would be 0.33. So now all you have to do is just roughly, if you have a pen or paper lying somewhere around you, just roughly plot these points and you'll see you have formed a beautiful house equation. So why then let me try to do this here. So, okay. So now I think you guys can plot this on the graph. You just simply have to put true positive values and the threshold values will be 0, 0.5, 0.2, 0.4, 6, 8, 1. Same on the x-axis. So if you calculate for the threshold of 0.8, you will have the TPR of, let me just write that, just in case, no. And FPR is 0. So when you plot it on the graph and you want your true positive rate to be the most, if you say your true positive rate is the most important or most, what do we say, important factor, then you would go for the point where your x value is 0. So from here you will start like using your point for ROC. But if somebody says that, okay, the false positive rate is not that important, then you can go to 0.661, right? Or 1, because false positive rate is not that important. Anyone would do fine. But if they say they want a perfect balance of your true positive and false positive, then you would go for this middle value. This one. So now that we have done the calculation of ROC, let's see. So as we have discussed already, the industry use cases of random forest, but I forgot to tell you about the decision trees. So decision trees is widely used in data mining, and it is used in loan approval. It is also used in finance sector, like forecasting future outcomes and assigning probabilities to those industry use cases. So like, fraud detection, random forest, whenever somebody says random forest, the first thing that comes to mind is that fraud detection data set or fraud detection model. in medicines, random forest is used. Why? Because complex combination of chemicals have to be done. So in that case, depending on random forest is better. Stock market, I have done personally used random forest for analysis of Tata Motors share recently, like a month ago. So I used random forest for that, and I had an accuracy of I think 89%. So I didn't believe it still, but I tried to just simply like work on like implement it in real life and see if it actually works. So let's sum it up for once. So till now, what I discussed with you guys is that decision trees is widely accepted because it's like a white box. You can see how your decisions are being made, how which factor is affecting your decision, which are the most important ones, which are the not most important ones. There is a factor called pruning. It comes in handy because you don't want your tree to be too long. We use pruning to eliminate some unimportant features and cut the tree. Like when you do it around your house, if the tree is too big, you just cut some branches or leaves of it so that it becomes more concise and structured. Right? So pruning, that's an important factor. Then we know that decision tree performs well with nonlinear data. It's specialized in performing with nonlinear data. Decision tree tends to overfit. Okay, but as we know that there are various ensemble techniques that we can use to mitigate this issue. Then random forest is an ensemble of decision trees, and random forest is widely popular. Why? Because it handles missing value very well and it tends to not overfit. So that ends my presentation today, and I hope you guys were able to learn something. While preparing for this presentation, I got to learn a lot of new things which I was not aware of. It was a really like enriching experience for me. I hope I could impart some of that to you guys.
Thank you so much, Anu. That was wonderful presentation also. And I think if we are up to certain questions, if you want to take up, I think we can open it up for the people. So you guys can definitely, put up your questions over here, and we are always here to answer you guys. So let's
ask the questions here, Slack or LinkedIn, anywhere.
Yeah, Anu, there were two questions from Shubham. In the question and answers, the answered one, the last two questions. Yeah, so maybe if you want to add anything to that, maybe you can.
Okay, yeah, let me just answer once. Okay. The last two.
What is the reason for overfitting in the random forest, and how it is minimized automatically?
As I said, it is minimized because you see overfitting occurs when you have just like one tree, right? But when you have number of trees working, and you see here the variance is like almost cancelled out. So as I said, high variance is converted into low variance. Right? So there is not much of an issue of overfitting when it comes to random forest. Random forest is basically like overfitting when we stack up some ML models, different ones. Here we are stacking up decision trees. That's the only difference. So tagging is one that tends to mitigate overfitting to a lot of extent. And okay, in case of random forest, what is the reason overfitting is overcome?
I think you just answered that.
Yeah, both are same questions.
Yeah, similarly. So I hope Shubham, you have understood the answer that Anu has given.
In case
You were
you're
reducing the
still
noise, so that
confused
means I was
about
too
it,
loud.
I can. Huh?
I was too loud or what? You were reducing the volume.
And no, my earphones. I mean, I'm not still used to these ones,
Okay, okay,
bulky
that's
ones.
good.
Yeah. So yeah, okay, Shubham, you
Okay,
got it.
Shubham, I
Okay, cool.
think
But just in case, I'll just share some like links from which I got my things up and running. Then I'll just
yeah,
share those
sure,
links with
please
you.
do.
You will have a better understanding when you have multiple examples, right?
Definitely, definitely, please do. I think I'll share a
Okay.
book that I already have. So maybe that should give a lot of other experience to people who want to learn in depth about deep learning and random forest. Because what I believe is along with random forest and decision tree, they are particularly used in, the autonomous, this thing, vehicle drive. You can say automatic vehicle driving. So that's where it is mostly used. That's what I saw in recent times. And also the dance movement that people are coming up with, and the facial recognition during that
Facial
purpose also.
recognition, yeah, yeah, a lot
Yeah,
of
that
things.
does use this thing, random forest also. And I think recently there was this ad with if you are in India, you definitely have seen that ad with people playing that ping pong through this kind of stick. I think if you might have seen that. So that also uses and tracks the movement. Along with that, there is a transmitter in that particular stick. There is a ball over it, and there is a transmitter inside it. And that uses this random forest model in that transmitter. So that tracks the movement as you are moving. And on the screen, you can see once you put up a badminton shot or ping pong shot, that uses that tracking movement and transmit to the screen. So that also uses this ML modeling. Yeah, it's the Nintendo Switch. Correct, correct. So that definitely comes up. I mean, I don't remember exactly the complete ad, but I have seen it. That Ranveer Singh and those two people are playing up in the like a cricket shot, and some are playing with table tennis or say badminton, something like that. So that also uses this particular kind of technology.
Okay.
Yeah.
Request
So there was
please
another
share Slack
question.
or Discord channel reference. Not sure. I didn't get the question.
Okay, okay, sure.
What reference?
I think you have the Slack channel link. I don't
Mine?
have it right. No, the Newton AI Slack channel link.
Just that one, I think I have.
Yeah, definitely. It can be used in VR like things. I'm not sure if you guys have heard about virtual sampling kind of thing. If you have, there is this, you can say the lens cut. Have you seen lens cut? I think all of you must have seen lens cut. So that uses the facial recognition, and that also catches the movement of the eye. And it also uses the OpenCV, and I think it uses TensorFlow. It also uses neural networks, but somewhere it also uses the random forest also, and the decision trees also, because you have to track the movement of the face, right? It
Yeah.
moves from the left to right and then right to left. So that uses the complete tracking movement also. So that also uses the decision tree in such a way that if you're using, say, if your face is round, it captures that particular facial dimensions and all, and that will put up a conclusion over that. Yeah, okay, this person's face is round, and you need to show them this particular this particular set of goggles, or say lenses or something like that, the glasses. So that also uses the decision tree. I hope that gives a bit idea. The VR is kind of it's based upon Unity development. The Unity development also uses this thing, uh, the machine learning models, but the VR is mostly on the front end kind of thing. Okay, the background, or you can say the logic behind that particular coming up things over there that is on what we see is completely based on ML models. Not exactly completely, but yeah, most of the things are built upon ML models, machine learning and artificial intelligence models. So yeah, definitely VR can be used. It can be used in VR things.
I cannot find the link right now.
Yeah.
Keep down.
I hope this gave some idea about some things on the industrial application. That's good. That's good. Yeah, I would request Ilya if you can share the Slack link on this chatbot. If it is possible for you to share it, I think that would be better. Shubham, you can share your email address.
Yeah.
And I think I can try to add you up using direct connection. So I think I can add you up directly from the phone. Try to. Okay. So do let me know once you have your email ID. And yeah, if you have any more doubts with regards to decision tree, with regards to random forest, their application, and what else things can be done along with this, random forest and decision trees. So you can definitely let us know. Yeah, I think Shubham, there is a link in the chat box. You can copy that. You can click on it, and you can connect on the general channel. So once you are there, I think you should be able to see all the list of channels over there. Okay, so join all of them, and if you haven't participated in the competition that we held, so maybe you can try modeling it on your own. I mean, at least attempt the third, the thing, third task that can be definitely done. Okay, and apart from that, I would say like people who are facing still facing some issues with the task, do let us know. And the third task is extended till today midnight on Indian time, or whatever time zone you are in. I think there are people from Turkey also. Some people are from, I think, Australia also. So it's for them also. I think people who are watching us live, or maybe who are going to watch us, so it is supposed to be for them also. That this competition is till today midnight. That is on what the date today? It's on 9th. Yeah. So it's 9th midnight. You have to submit it. And you have to submit two things, particularly your answer with the code, and it should contain the complete things from the Kaggle. You need to upload this data set on. You need to model it on Kaggle, and you need to share that complete code on the Slack channel. Okay, along with your answer. I mean the accuracy score or whatever score that you have got. Okay, I think that should be clear with you all. And yeah, that's Anugna's LinkedIn ID, so you can definitely connect with her. And apart from that, Anu, can you also share your GitHub ID? Maybe that could be helpful for people to look into the project that you have already been working on, or maybe you have already completed. So that would be also be perfect to for everyone to look into and get some guidance. Yeah. So I believe if you guys have any other kind of doubts, questions with regards to any other thing, you can definitely reach out to any one of us, and we are always there to support you. Okay, so tomorrow we'll be covering up the practical aspect of decision tree and the random forest. Okay, and what we will be doing is two things. First, we'll be collecting up all the algorithms that our previous speakers have spoken about on the classification. say logistic regression, SVM, and the QNN. We'll collect them, and even decision tree and the random forest. After that, we will collate them and see which model fits the best. Okay. After that, we will also look into the Newton's platform. Okay, and we'll run up the same model over there on Newton's platform and see the accuracy score over there. Okay, and then we'll put up a comparison. Which models have was fitted the best. Okay, either it's from Newton or it's the one that we created. Okay, so I think that should give you a good idea about tomorrow's event. And tomorrow we'll be declaring the winners of all the 3 tasks along with the scores, and we'll be giving out the rewards as well. Okay, so I believe this was a wonderful session from Anu. So thank you all of you. If you guys have any kind of doubt, do reach out to us, and we are always there to support you, as I say always. And I just don't say, I do support you guys. So that's one of the things. So definitely reach out to us, and see you for today. Thank you so much, all of you, to support us and be there with us today. And have a great weekend, definitely. And do enjoy the Garba. Okay, yeah. Thank you everyone. See you guys. Bye bye. Have a great day.